The last equation to talk about is the fourth one, which tells us the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the final position minus the initial position. This allows us to find velocity, position, or acceleration without knowing the time. Notice how all of the other equations use time in some way. This means on all the problems you'll be solving today, you will never be given the time. For the first example, we have an object that accelerates from rest with a constant acceleration of 6.2 meters per second squared. How fast will it be traveling after it goes 68 meters? We always want to start off by writing our equation, which is the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times final position minus initial position. You could also think of this final position and initial position coming together to just be the displacement of the object, if you want. We can identify all of our information, and we have the final velocity, which is what we're trying to find. How fast is it going at the end of the distance? Initial velocity, it tells us that the object started from rest, so it will be 0. Then we have the acceleration, which is 6.2 meters per second squared. And then the last thing to figure out the final position and the initial position, you can think about it as displacement and put in the 68. But the reason that works is because we can assume that it had a 0 initial position, meaning it traveled a final distance of 68 meters. Then we'll go and we'll plug our information in, and we'll have final velocity squared is equal to 0 plus 2 times 6.2 meters per second squared times 68 meters. We'll cancel out the 0, then we'll be left with final velocity squared is equal to 843.2. For the units, we have meters times meters, so that'll give you meters squared over second squared. Last thing is we need just the velocity, so we'll take the square root, and velocity is going to be equal to 29.0 meters per second. And it's going in the positive direction. Also notice how your units, when you take the square root of meters squared and second squared, it will turn out to just meters per second. Next, we have an object that accelerates from rest to a speed of 24 meters per second north over a distance of 56 meters. What acceleration does it experience? We have our equation. We need to identify the variables. We know the object starts at rest. That gives us 0 initial velocity. Then it goes to a speed of 24 meters per second north, which means the velocity is positive 24 meters per second. It asks us to find the acceleration. That's our unknown. Then it tells us it travels 56 meters. We're going to assume it started at 0 and it ends at 56 meters. So we can plug things in next, and we'll have 24 meters per second, all squared, is equal to 2 times the acceleration times 56 meters. That's going to leave you with 576 meters squared over second squared is equal to 112 meters times your acceleration. Divide by 112 meters on each side, and you'll have a final acceleration of 5.14 meters over second squared. But we also need to include that this is going to the north since it's in the positive direction. If you're wondering how your units works out, this is what's happening. You're having meters squared over second squared from squaring your velocity. Then you're dividing it by meters. To get rid of meters, we need to multiply it by the reciprocal, which would be 1 over meters on both the top and the bottom. That gets rid of everything down here. We can cancel out 1 meter on the top, the meter on the bottom, and that leaves you with meters over second squared. Last example, we have an object that has an acceleration of 7.9 meters per second squared south. As a result, it accelerates from rest to 35 meters per second south. What is the distance it travels during that acceleration? We know that the object is starting from rest, so we have a 0 initial velocity again. It then is going 35 meters per second south, which tells us that the velocity is going to be a negative 35 meters per second. Then the acceleration is 7.9 meters per second squared. And again, it's going south too, so don't forget to make it negative. Then, since we want to know the position that it ends in, or the distance traveled, we're going to assume it starts at 0 and it ends at some unknown distance. We'll plug all these in and solve. We'll have negative 35 meters over seconds squared is equal to 2 times the acceleration, negative 7.9 meters over second squared, times our final position. And I'm just leaving out anything that would have been 0. That's going to leave you with 1,225 meters squared over second squared is equal to negative 15.8 meters over second squared times the final position. Divide both sides by negative 15.8 with your units, and you'll be left with negative 77.8 meters equals your final position. Since it's strange to say that the distance is negative, we can rewrite this as 77.8 meters to the south.